Welcome, everyone.
Buenos días.
So I apologize for so much English so early in the morning.
It's great.
That's all right. So my name is Justin Coleman. I'm the Director of DTK and Layout Automation, Center of Excellence at MICRON. And I'm going to explain a little bit about what that is and what that means. But first I wanted to give you a little bit of a background on me. So I've been at MICRON for 29 years. I spent the first 4 years doing layout and working in the layout team in Boise at MICRON. And then I helped start the layout support CAD team at MICRON, which is where I've been ever since, and now I run that team. So that's a little bit about me. Now let's talk about what is CAD. You want me to start over? Okay, so let's talk about a little bit about what is CAD. And first I want to set some context. So if we think of a standard DDR5 chip, there's over 16 billion transistors and 16 billion capacitors just in the memory array, and then there's a whole set of periphery logic that is on top of that. That's a very big number, so I want to talk a little bit about what that number means. And so if we think about that in like things that we're more comfortable with, that's around 4x the total number of people that are on Earth right now today, right? That's the same number of people that would fill 457,000 football stadiums, right? If you put 1 millimeter beads stacked end to end, you could go 80% around the circumference of the Earth, right? So this is a massive number, right? And if we think about it, if you think, you know, how does somebody interact with this? If you did one thing a second, it would take 1,014 years to do 32 billion things, right? So this is a massive amount of stuff, and it's very small, right? That chip is about the size of the tip of your finger, right? So it's super tiny, super complicated. So let's talk a little bit more in context. So let's assume you have about 25 people to do the logical design, right? Figure out the electronics, how we want to hook this up, and about 25 people that want to do, or that will do the physical design, like actually draw the shapes that we're going to put onto silicon. They have about 6 to 9 months, depending on schedule, to do all that work. So they have to design it, they have to lay it out, they have to meet all the DRCs, they have to meet LVS, they need to do parasitics, do all the verification, and then send that to fabrication. How do you have such a small team do that much work? And the answer to that is automation, right? You need ways to make the work simpler. And so that's kind of where CAD comes in. So CAD is really a misnomer. Do you guys know that word, misnomer? Like a name used wrongly, right? So in the beginning, all layout was done on paper and on mylar, which is like plastic paper, right? And so this is what a layout team would have looked like in probably the early 80s. And then, even though they were designing computer chips, they weren't using computers to design computer chips. And then somebody, you know, some guys from National started a company called Calma to help automate and make this faster. And so they brought computers in, and you could do this work inside of computers instead of on paper. And when they did that, you had a bunch of people who were used to drawing things, and they needed help. Like, how do we use these computers? This is new technology, this is hard. So they hired in people who could help them with the CAD tools, computer-aided design, right? And so forever, since that point, within our industry, the people that help support the tools and build the tools and create automation are known as the CAD team. Even though in other industries, like if you went to mechanical engineering, if you said CAD, it is the person using the tool, not the person building the CAD tools. So that's a little bit of a misnomer. Outside of the industry, they would call what I do is EDA, electronic design automation. But if you were to go to Intel or Micron or NVIDIA or Apple, and you asked about like who supports your tools, they would say the CAD team. So our CAD or EDA teams have many functions, but really our number one goal is to make the impossible possible, right? We go back to like, how does 20 people do 32 billion things, right? You need to use things like hierarchy, which is what Claudia talked about yesterday, right? And you need to have automated tools, right? You don't draw every transistor. You have a tool that draws the transistor and you place it. You don't connect 500,000 connections. You have an automatic routing tool that makes those connections. You don't manually run 100,000 simulations. You have tools that prioritize your simulations and run them and then check the results and flag things for you to look at. So at CAD at Micron, and it's probably different other places, but we break our CAD team down into 4 main disciplines, and we use the term Center of Excellence, and that just means that this is the team that is responsible worldwide for all business units, so DRAM, NAND, emerging memory, for these tools and these technologies. And so we have the environment team, and they do things like tool installs, like installing Virtuoso from Cadence, Calibre from Mentor, Synopsys simulation tools. They handle all that. They set up infrastructure, things like our revision control, dashboards for managers to check and make sure people are getting their projects done. Yet all of those things fall into the environment category. We have what we call the front end, and that's really the logical design, right? Schematics, simulations. Simulations is probably the biggest portion of that. For a DDR5 part, we will probably run somewhere between 500,000 and 1 million simulations before we tape that out, right? Because a reticle costs anywhere from $20,000 to $300,000. Anything you can find, any problems you can find before you tape out, not only save you the money from that reticle, but they save you the time, right? And you look at a complex state-of-the-art foundry process, it might take 4 months for you to run that part through the fab. If you find out you have a problem, you not only have to buy a new reticle, you have to start over all that product, and all that product that you've been waiting months for is no good and it's garbage, right? And so that opportunity cost becomes like a really big thing. We have the back end, and that's what my team does, and that's all the physical design, so all the layout-based tools. You know, we build P-cells, automated routers, custom scripts that help meet design rules and help convert data from one process node to the next node, because as we move forward in time, geometry shrink, rules get tighter and more complicated, right? And we need ways to make that faster and easier for the teams like Claudia so that they can still hit schedule and that they can still go home at night and see their families. And then we have the physical verification, and physical verification is really where everything comes together, right? You have your logical design, the schematic, and you have your layout. You need to make sure that that matches and it's hooked up correctly. And you also need to make sure you meet all the design rules. And if you think about design rules, they're like building codes, right? You know, if you build a wall, the wall has to be built a certain way. If you put in a door, it has to be so far from a corner and so far from a window. We have similar things for every layer that we build. At Micron, on one of our advanced nodes, there's currently about 12,000 rules that cover all the different layers. And so it's a pretty complicated process, and that all those rules need to be able to run, and they need to be able to run pretty quickly. The standard of excellence for a DRAM part is we want to take our full chip, which is a 16 gigabit DRAM, and we want DRCs to run in less than 2 hours, and we want LVS to run in less than 30 minutes. But if it's longer than that, people get upset, right? Because they need to be able to run DRCs, fix some things, run, fix, and you want to have as many of those cycles as you can during a day so that they can meet their schedules. Any questions so far?
Just to be curious, you said how much time those DRC or LVS must be is convenient for you. You told us that. You mean that your team has to run the DRC?
No, we don't run the DRCs, but so we write the DRC rules.
Ah, okay.
And if it takes too long, we have to go into the tool and try to figure out how can we write the rule different so it can run faster. Or maybe how do we check the problem in a different way? Because there's always multiple ways to do something. And so maybe you can come at it at a different angle and make it faster. Because again, it's a small team and you're trying to make everything as smooth and as efficient as possible, right? If you have 20 layout people and you're at the end of the part and they're all fixing DRCs and they press the button and it takes all day, what do those guys do all day? Right? We're still paying them. They still have a deadline, but you know, they need to get work done. Like, you know, so we spend a lot of time fine-tuning and making everything work smoothly. And same for like the stuff that we do. So my team, we have about 300 P-cells that we own. And P-cells, when you open the data, it runs the code and it evaluates and it builds the layout based on whatever parameters you've set. That execution time becomes very important because if your code is not so efficient, it takes a long time to open the data. And if people have to sit and wait, then they complain. Right? So we spend a lot of time trying to make sure that not only does the code meet all the rules, but that it's very efficient and that the time spent doing it is as short as possible. Thank you. Cool. All right. So we'll talk a little bit more in detail about what each of the teams do. So environment, tool installs, Linux setup. We do almost all of our work in Linux. Everybody has a Windows PC, and then they have a virtualization tool that we use that opens a Linux desktop inside of Windows, and they do all their work in Linux. So all the database, everything is there. Not all of our users are Linux experts, so we try to help them with tools that make their life easier. You know, lots of GUIs, make it easy to check in and check out files, those kind of things. Revision control, so everything we do, we revision control. That way, if somebody makes a mistake, you can get back. If somebody changes their mind, or you know, if we do an experiment on a part and we don't like it, you can always go back. I assume you guys understand what revision control is? Yeah, like Git, right? Database syncing. So this ends up being a big part of what this team does. So we have design centers in Boise, Texas, San Jose, and Atlanta in the US, as well as Guadalajara in Mexico, Hashimoto, Japan, India, and Munich. And so all of those teams work together. And so when one person makes an edit, somebody halfway across the world needs to be able to see that edit real time. And so you're talking about big binary files that have to be synced all over the world in real time, and so that people don't notice a problem. And so that there's a lot of time spent managing how you get all that data everywhere so that it's seamless for the user. Dashboards, like I mentioned, one thing, you know, you guys might not have experienced yet, but when you work for a company, you have bosses, and bosses always want to know what you're doing. But they don't want to know lots of detail. They want a summary. And so we spend a decent amount of time building dashboards that take a really complex thing, like what is the status of a few 100,000 cells in a project, and summarizing that so that upper level management can look at it and see, you know, is this part on schedule? Is it behind? Does it maybe need more resources? Are they ahead of schedule? Those kind of things. Language installs. So we use a lot of different programming languages. We have to install those, make sure that they have the right packages, that they're up to date, all those kind of things. And then cloud interfacing and job management. So in the last probably 5 to 10 years, the cloud has become a really big thing. It can be expensive, but it's also very powerful. So we have an entire system of when jobs are created, and those jobs could be a simulation job, a characterization job, a DRC or an LVS. There are compute resources at every site. And so at the first level, the system will look and say, is there resources at our site? And if not, is there resources at another site? Can I move that to the other site and then pipe the results back? And if not there, can we burst out to the cloud and still get this job run and then bring the results back? And so that's a whole system to make sure that that all runs and is relatively seamless to the user, because you don't want the user to have to submit a job and says, oh, you're out of resources, go submit somewhere else, right? We want that to be a smooth and painless process. Front end, So the main focus here is the logical design. And the actual schematic portion of the design is really the lesser part, probably, of the work. The major portion is doing the simulations. And so you'll have things like SPICE simulations, Verilog simulations, reliability simulations, right? Because the ideal is we want to test the chip as much as we can before we make silicon, right? Because once you make silicon, you've already, you spend a bunch of money, you spend a bunch of time, right? The more you can test it, and you think about it, like Toyota, right? You guys know Toyota? Toyota shoots for 99.9% quality. That's their goal. I think they're very good at that. They're probably one of the best car companies at that. Every wafer we make has roughly 1,000 die on it, right? And we do 200,000 or 300,000 wafers a week in each manufacturing plant, right? If we were at 99.9% quality, we would throw away millions and millions of die, right? So we have to ramp up to crazy levels of quality to make sure that we're efficient because we're in a commodity business. Obviously, right now DRAM is crazy expensive, but generally, these chips that we spend all this time building, you have billions of things, and it's 6 to 9 months worth of work, and we sell for $3, right? So everything's about efficiency and making sure that we're doing things in a way that puts us in the best chance for success. Back in, so these are all the layout tools. Our layout is incredibly complicated. I think I was talking to somebody yesterday. One of the problems that we solved 8 or 9 years ago is light has a certain wavelength, right? And then that wavelength can be measured in a physical distance. And we use light to shine through a reticle and print a pattern on silicon. What happens when you want to make a feature that is smaller than the wavelength of light? How do you break the laws of physics? But you can't break the laws of physics, but you can bend the laws of physics, right? And so we spend a lot of time figuring out how to manufacture things that are below the wavelength of light, right? And when you do that, there's lots of weird optical effects that you account for. We build in special features around our dense feature set to account for that. We have mechanical stress issues that we have to worry about because when you're building things so small that the actual mechanical stress created causes things to behave badly and shapes to move. And so we have to account for all that. As Claudia noted in her presentation, everything we draw is drawn in 2D, top down. But and here, this is an actual picture, which looks like nothing, right? It's just a whole bunch of shapes on top of each other, and you can't really see. But that really becomes something like the thing on the right. And so there's a fair amount of time, building tools to make it easier for people to understand. The picture on the right came from a tool that my team built where we take one of these layouts and we render it in 3D so that they can get a better appreciation of how things connect, how things interrelate, because as a layout designer, they have to always consider the entire stack of the die, right? They never get just to build one piece. They have to consider that all. And there's, of course, a super high emphasis on automation. In the design flow, the first thing that happens is the logical design, and the last thing that happens is the layout design. And so if the logical design is late, the layout design has to make up that time, right? And so we always need ways to do everything faster, more efficient, spend less time on it. Physical verification, so this is design rule checking. And you can kind of see I actually made some errors in that particular layout, and if you look, it might not show up super, there's like a little yellow trapezoid there. That's indicative of what a DRC flag would do. So if someone like Claudia made an error like this, she would run the tool, and then she would have to go look at that case and then figure out how to fix it. And that might be as simple as moving one shape, but it might be as complicated as moving entire sections of the design, right? So making tools that run quickly, building helpers that help them correct by design, saves them a lot of time. If they were to build a very large block and and not take into account a design rule, they could get into a place where they have to redo a lot of work. Similar with LVS, that's a very critical thing for us, where we have to check and make sure that, do we have the right number of devices? Do we have the right kind of devices? And are they all hooked up correctly? We also have what we call compare, which some people would call LVL, which is layout versus layout. So once a chip tapes out, it's never done the first time, right? Because even if the chip works, there's always opportunities to improve yield, to improve quality, to improve speed. And so as you start making changes, you will make changes on a per layer basis. So you have 60 to 80 layers that you've taped out, and you might change 2. So if you go and make changes, you need to make sure you have a way to ensure that you only change those 2 layers, because everything else has to stay static. And so we build tools to help with that. And then the big question is, how does AI play into this? And AI has actually been in place for a long time in EDA. Pretty much every placement and routing tool from every big vendor is using a machine learning algorithm already. But we're seeing that accelerate at an incredibly rapid pace. And it's worth noting that the advancements are incredibly rapid right now. A year ago, we were talking about how to pick the best models and you know, what were our best methodologies for coming to the best solutions. Almost all of that is obsolete today, and everything is about LLMs. So we're at a stage right now where the entire world is upskilling every day to the new AI standards. Right now, what do we use it for directly? Right now, the biggest impact that we're seeing from AI is, of course, code assistance for programmers, right? Things that can help you kick out, you know, your prototypes and your boilerplate code, things that can help you evaluate and understand code that maybe somebody else wrote. We're seeing really big advantages in data analysis and debugging. We have built agentic tools that help you debug LVS and that help you debug DRC, and that can take, you know, somebody who might be relatively new to design or layout and allow them to more quickly understand what the tools are telling them and get their chips clean. We're seeing huge advantages in prototyping, you know, things that, you know, would have taken a week or 2 of sideline time now can be prototyped in a couple hours. Work is still needed to be done to make those things, you know, production level, but just huge advantages there. More advanced AI tools are under work. Every major vendor is working on major AI tools. We are doing so as well with our internal development. Where those go will be a very interesting thing. AI is a very powerful tool, but there's also some interesting ethical questions. You know, for like a company like us, if I asked AI to make me a flip-flop, it absolutely can. It could design me the schematic for a flip-flop. Is that a patented flip-flop that maybe Samsung built? Because where did that AI tool get that knowledge? Because if that's a patented IP, that's a problem for us. And so we have a whole team of people who are working on what we call redlining, which is the ability, once you've used an AI tool, to make sure that whatever you produced with it is not protected IP from someone else, right? And so that will be an interesting thing. And then one more thing I wanted to say about AI, because I think it's interesting. When I was your guys' age, the internet was just becoming a thing. I know, I'm really old. And when that happened, like there were some of us, the young people, we were very excited. We were like, the internet is going to change the world, right? Like everybody's going to be able, like, we're never going to have to go to school again. It's all going to be on the internet, and like there'll not be encyclopedias, which turned out to be true. And, you know, and then like all these things. If you would ask the younger Justin, will the internet be the place where you buy everything? I would have said, no, why would we use the internet to buy stuff, right? Like nobody saw that coming. I think AI will be the same thing. I think AI will change the world. I think it probably won't change the world in the way that we're expecting. And I think it's going to be really interesting to see where that goes, because it's probably going to solve problems in a way that we didn't quite envision. All right. And then my final slide, what kind of candidates do we look for? What are the kind of characteristics that for CAD stand out to us? First off, we like people who enjoy solving problems, right? The number one thing that my team does is solve problems. And they're not necessarily like, what is 1 + 1? It is, here's a problem that no one has ever seen, and how do we solve it? For example, we had a chip a few years back that was failing in the field. The product engineering team went and looked at it and did some investigation, and they figured that that their supposition was that a neutron strike was happening, and if a neutron strike hit in just the right place, it would hit a wire. The wire was so narrow, it would change the charge of the wire, and it would cause the chip to malfunction. And so we had a hypothesis, so we took a tester to Los Alamos, and we shot the particle accelerator at it, because that's the only way we could think of to make a neutron strike happen. And we were able to duplicate the problem. But now, we had a new problem, which is we know why the chip malfunctioned. We can't shield for neutrons, they go through everything. How do we fix that problem, right? And so that becomes a collaborative effort of design, of fabrication experts, of CAD, sitting down and saying, okay, if a neutron can hit any wire on the die, how do you identify which wires are vulnerable, and how do you change your circuitry in a way that if a neutron strikes, it doesn't cause the chip to malfunction? And so those are the kind of problems we solve. We really work as CAD in a cross-disciplinary manner. You know, we do electronic design work, we do programming work, we also heavily collaborate with mechanical and chemical engineers on the fabrication side. And we kind of bring all those people together. And so if that's the kind of thing that you like, if you like solving problems, you like challenges, that is a huge thing. We like people who like to learn and grow and face new challenges. I've been at MICRON for 29 years. I learn something new all the time. The programming languages I started using aren't the programming languages I use today, right? Those things change over time. The techniques I use are different. You know, so we like people who like growth and who want to continue to do different things. We like people who have a passion. And we like people who have a passion for not just electronics or programming, but really say, I like electronics and I like programming. How can I bring these together, right? How do I make things better? We also like people who want to learn more of the big picture, right? If you work in logical design, you will get to know everything about logical design. If you work in layout, you'll get to know everything about layout. If you work in process integration, you get to learn everything to know about process. In CAD, we get to work with all of those people and help bring everything together, and so you get a bigger sense of how the whole thing comes together. We do tons and tons of collaboration because we work with so many teams and we get inputs from design and process and product engineering. And so people that like to work with other people is always a good thing. And then we like for people who always look for ways to do things better. Is there a better way to do this? Like, let's experiment, let's try some things. Can we do this faster? Can we do it more efficiently? Can we do it better? Like, even if this is the status quo, is there room to do things differently? Questions?
In my case, because I'm a professor, you know, maybe the theory is so different from the reality that you live in MICRON. So how I, as a professor, can be prepared to give lectures to my students and probably, maybe, go to work to MICRON?
That's a good question. I think everybody has to start somewhere, you know, and I think the theory is always different than reality, but it's a good basis. It's not a long ways from what we do. Obviously, if we had a close relationship with you, you could probably fine-tune your stuff closer to us, but that's probably different than what Intel does or someone else. For us, I mean, education is very important, but it is really the first building block, right? When we bring people in, we have an entire onboarding system to teach them, you know, the MICRON way, the MICRON process. We have a giant lexicon of all the acronyms and phrases we use that nobody understands, and you know, some of that is just stuff that you have to learn, I think.
Just, I'm also professor, but I think that theory is good. Well, a question is about in your practice when you are facing new technological nodes. I mean, for example, I think that you have very different clients trying to demand for some products. They say, for example, let's have to work with global foundries, 180, or something smaller in the nanometer scale. But every time you face a new design, in your case, in layout, you have to learn the particular details of that technology, for example, and how do you face your designs? Because you have, I don't know, for example, a certain block of analog design, but you have to put it in a legacy node, or you have to you have to put that design in, you know, for example, 22 nanometers or something like that. So what are the difficulties of your teams, or what do you do in that case? How do you face that?
So for us, for the most part, that problem gets a little simpler in that MICRON develops its own process, right? So when we get to the next advanced node, the guys who designed it are down the hall, right? So whenever they're designing it, one of their first calls is to my team, and we will sit down and we will talk through not just the rules, but the why behind, because sometimes the rules don't always convey the spirit of the law, if you will. And once you understand the spirit of the law, then maybe we'll have them change the rules to better understand that. But then we will adapt the tools to go along with it. And then we come up with ways to make sure that that's documented well so that everybody in the design community can understand. And one of the biggest challenges for us as a global company is you might have a process that's designed in Boise. And so all of the documentation and all of the thinking is very American English based, if you will, which could be a challenge for somebody in Mexico or somewhere else. Or it could be a process developed at our fab in Hiroshima in Japan, and then all of the language and stuff is very Japanese based, which does translate into English, but sometimes not as clearly. And so trying to find ways to communicate across different things in Japan that is a challenge for us Americans is they like double negatives, you know, where we would say you have high density and you have low density. And they would say we have high density and high density not. Right? And as an American, we're like, I understand what you're saying, but why would you say it that way, right? That's kind of weird. And so that's something that just is a challenge of being a multinational corporation.
Hi, I'm a student and I want to know how it's different to work with RTL or cadence. It's different to in the student or the academy when have a change in the company is a different, or how we can learn or a specification that it's necessary to join with you.
So good question. For RTL type stuff, a lot of the basics is very similar. But for Micron, we do very little RTL. So a DRAM by nature is almost a giant analog block. It has asynchronous clocks. The entire memory array is analog. It has large analog blocks. So the vast majority of all of our design is traditional, full custom, starts with schematics, direct layout. Now we still have standard cells. Things are still built in automated fashions, but there's only small portions that are built with RTL. And one of the main reasons behind that is that we are a commodity. If you have any kind of a time enclosure problem, its solution is to increase space or add buffers, right? Which is good, like it solves the problem. It's not always the most efficient way and the smallest way. So we would use RTL on some of our advanced designs for like maybe a built-in self-test module or something like that, like a controller. But the majority is schematic driven. So if when people go to school, as long as you've done like digital circuits, VLSI courses, like those are good starting points. If you have analog courses available, those are always very relevant to what we do.
Hi, good morning.
Good morning.
My name is Raúl Acosta. I am also a professor here at the CIP in the cybersecurity laboratory. I would like to know about your usually cybersecurity tasks or objectives that you have in your company. If you could talk us about a little bit, please.
So we have a lot of cybersecurity. It makes life very hard sometimes. So we actually had a problem in our Taiwanese fab where the Chinese government had paid Micron employees to stay at Micron and copy data and take it to China. And so because of that, we have very, very tight cybersecurity. So all of our projects operate on a need to know. So for example, and I'm going to pick on somebody. So Claudia can see probably Y83Y and Y73B because those are the two parts she's assigned to. But she would not have permission to see E63A unless she was assigned to that part. And so that's the first step, which is compartmentalization. And then like any of the computers in our company, you cannot put a thumb drive into, you cannot, like certain documents you cannot screenshot or print. We have scripts that run automatically across all of your documents that look for keywords or phrases that have to do with sensitive technology and mark them as highly confidential, which means they can't be forwarded, or you cannot, certain people cannot be invited to meetings. And so there's an entire group at Micron that's all they do is security. The victim's the wrong word, but as a customer of cybersecurity, it makes things harder, right? Like it's more challenging to help people when you can't see their data and you have to go talk to a security person. But it's the way of the world, and especially as you do more things on the cloud, and there's more things are connected to the internet. The opportunity for bad actors to get in and access highly proprietary data is greater and greater. And when you think about a company like Micron, if you've spent billions of dollars developing a state-of-the-art DRAM process, you really want to put a lot of effort to make sure that that's not just downloadable on GitHub.
Hi. You mentioned that Micron had this problem regarding the Newton strike, and you worked to Los Alamos to make some testing. So I just was wondering, like, how was the procedure for making or for elaborating all these experimental procedures, since I guess you were forced to get in touch with external entities, since in Micron you doesn't have a particle accelerator in order to develop local research on those kind of things. And how is these kind of issues regarding, for example, in the US or in Mexico, when you need to collaborate with other companies or other institutions, And yeah.
So I wasn't involved directly with those discussions, but it came about really quick, and it looked to be relatively easy. One thing about being, what in the U.S. we would call a Fortune 500 company, where you're a very large company and people know about you and you're a large part of the economy, is that it makes it easier to do things, right? If like at the beginning when MICRON started, it was two guys who worked in the garage of a dentist, right? At that stage, it's probably really hard to go to Los Alamos and say, hey, can we use your particle accelerator? But if you're, you're a super big company and everybody knows you and you're well known, and like one of the things MICRON is very proud about is we have the largest number of patents of any semiconductor company in the world, right? And so in the scientific community, that brings a lot of prestige. So when we go to like Los Alamos and say, hey, we would like to collaborate, they say, that's awesome. And so that's been very helpful for us. And we have a lot of relationships with a lot of universities all over the world. And so when it comes to research and things like that, it's been relatively easy to make those partnerships because we have a lot of money, which helps the universities, and we hire a lot of kids, which also helps the universities. Any other questions? And just to say it, if anybody has a question and they're feeling too shy, come find me afterwards, because it can be intimidating to talk in front of people. I get that.
Okay. Well, you mentioned that the profile you are asking for is someone that has basis in electronics and programming. Would you be better than an electronic that don't have a good basis in programming, or a programmer that don't have a good basis in electronics? Which will be a better choice to join the CAD team and for trying that person?
That's a very good question. I think it depends on the person. I've hired both because you can teach. If someone has a passion and they're really interested and they have a good technologically based mind, right? Like they have that right mindset, you can learn electronics. You can learn programming, right? Both of those are there. It just really depends on the person. And so when we interview people, we really kind of try to get a feel for the people, and we try to get a feel for what that person really wants to do long term, and where their heart's desire might go. And if we find somebody that it feels like, yeah, this is the right fit, we'll train them.
And also, I don't know if you remember the slide when there were like 4 ceilings or centers of excellence. The first one, usually a person doesn't need to know necessarily electronics. It's full computer system, right? So as long as you know computers, as long as you have a passion to solve problems, there might be one part of CAD team that you can help with, right?
Well, my name is Lex Silva. I do have a little question. I think you just mentioned that in MICRON you do a very little RTL code. Yeah?
Yeah.
Well, my question is that what are your expectations about that? There were a lot of people that were only concentrating on doing like RTL code in the past, but now that we have a lot of AI tools, and I do not know the trendings for the next 10 years, but what do you think about all the people that only wanted to concentrate on digital designs, RTL code? Do you think they have the same opportunity as 10 years ago? Or do you think the AI tools and the trends and perspectives for the near future, what do you think about that? I was talking about this with my professor in the morning, so because there were in the past a lot of people that did not want to get into electronics because they only wanted to do like RTL code, And I think you understand.
So I would say Micron, I mean, because teaching RTL primarily in school has been the thing for 30 plus years, right? So we hire a ton of people that's the majority of what they learn in school. And you still learn the fundamentals of logic design, you still learn the fundamentals of simulation and verification and all those things. And those people adapt to full custom pretty readily. As far as the AI question, I think it's a great question. I think it's a question that a lot of people are asking right now. My perspective is this. When I started at Micron in 1997, one of the guys who was on my team took me aside and said, I don't know if anybody's going to be doing layout in 5 years. Right? Like it'll just be a button, it'll be all automated, you're probably not going to have a career. That was almost 30 years ago, right? I don't think any jobs are going anywhere. I think that as AI comes in, you will do more work, easier and faster, but they will always need the man in the middle, right? Like everything we've done with prototyping, with Anthropic and OpenAI, AI is brilliant and also stupid, right? And you need a person there to know when it's being brilliant and to know when it's not. And you need somebody to guide it and to make sure that you're building the right thing. I don't think that changes. I think that what might happen is there will be kids who say, I don't know if computer science is the right, it's too scary. I'll go to business or I'll go to mechanical engineering. Or I think we're going to see that. And I think that it's going to make a weird dynamic in the business where it's hard to find people because there's not as many people graduating, and then that pendulum will swing back the other way. But I don't think there's going to be any lack of need, and in fact, I think as we see AI go crazy and like what we're seeing now, I mean, we are building 6 mega fabs in the United States right now, which is crazy. Like, you know, and we're just going to see, we're going to need more and more and more and more people to design chips. Okay, thank you. We have time for one last?
Probably last question.
Okay, last question in the back.
Yeah, thanks. Sorry for getting here started. The question is more related with the process, how you do the validation. Probably, as I know, you work with Synopsys hand to hand, or do you use simulator? Do you use FPGA farms? How do you do your regressions in order to validate something? In this case, MICRON is focused on DRAMs, right? It's not focused in CPU or something else. Your goal is the focus you are in is the DRAMs, right?
Yep.
So what is the process? And the other question is, how long does it take to ramp up in your company? Because even if you are in the same field, it doesn't mean that you are gonna know everything. Because actually, you mentioned something really specific, is that the information is really close, right? It's restricted and many things. So the question here is, how long does it take? How long Micron take to the people that is getting in to ramp up? And I don't know if it's like a process that you're gonna have someone teaching you, hands with you, or how is the process? Or you need a very, very specific background? Because actually, I saw your opens, for the company, and there are like specific things, that probably I don't know, even that if I'm working in another company related with the same things, So it's the only question that I have. Thank you.
Okay, so 2-part question. First part, we'll answer the last part first. What do we do to bring people on board and how long does it take? Generally, like an NCG, within probably 1 month, we'll have you doing some real work, right? We'll teach you some stuff, you'll do something. We'll teach you some more stuff and you'll do something. And that will continue for probably 6 to 9 months. And probably for a brand new NCG, till the time that you get like fully proficient, there's not more stuff on like the learning and taking on more responsibility. It's probably somewhere between 18 months and 2 years in CAD to get to that full level. If you're coming from another company, that time is less. When we onboard people, we always have a 30, 60, 90-day plan that like this is what you're going to learn in the beginning, and you always have a mentor and a buddy, right? And we do that throughout your entire career. Micron also has a massive, I mean, we're a really big company. We have nearly 60,000 employees. So we have what we call Micron University, where you can take all kinds of courses, and you can even get like what's essentially a master's in AI development just through Micron, right? That we just provide directly to students, and we do, like if you want to go back to school, we pay your tuition, right? So we really focus on growing and helping you grow there. Then remind me what your first part of your question was around.
With synopsis, how do you do your regression?
Regression testing. So we use all the vendors, and we bounce between Synopsys and Cadence and even sometimes Mentor. Whichever tool gets us the best results fastest. And for us, there's a huge advantage against, bouncing around sometimes, because if we tell Synopsys it's like, oh, Cadence Excellium is way faster and it found more issues, then Synopsys has a very big interest in making their tool better, right? And so we do a lot of that. And then we have a very large test suite for regression testing, and we also built a tool that we call internally TAV, which is timing accurate Verilog. And so it gives us a way to do Verilog regressions with timing, right? Which traditionally, if you want a timing level simulation, you need to run HSpice, which is very accurate for timing, but takes a lot longer. But if you can get your regression level test, which is very quick at Verilog level, and you can get timing from it, that becomes a very big enabler in being able to do your massive regressions. We generally run somewhere between 500,000 and 700,000 Verilog jobs a month at Micron, and so we do a lot of regression testing across a lot of parts. And that's a very heavily automated flow where the users do not have to spend a lot of time submitting jobs and validating stuff. But if you want to know tons of stuff about verification, the man in the gray shirt sitting next to Claudia, Victor, is Mr. Verification. He could probably answer lots of things about that. So thank you, everyone, very much.
espacio y por poder compartir con todos ustedes un poquito de mi experiencia profesional, un poquito de mi experiencia personal a lo largo de la ingeniería. Mi nombre es Ivonne Alfaro y a estas experiencias que voy a compartir con ustedes les puse más fuerte que el miedo. Entonces, espero que les sirva de ayuda. Les voy a hablar un poco de mí antes de hablar sobre el tema en sí. Mi nombre, de nuevo, es Ivonne Alfaro Flores. Aquí en morado son los diferentes roles que he tenido a lo largo de mi carrera profesional. Básicamente empecé como ingeniera de validación eléctrica en Intel, en Guadalajara. A muy grandes rasgos, el diseño de circuitos semiconductores se divide en dos, el área presilicio y el área de posilicio. En el área de presilicio está verificación, layout, CAD, RTL, etc. Se corren simulaciones, etc. El área de posilicio está más enfocada en lo que es ya trabajar con el producto terminado y que se validan user cases en un sistema, por ejemplo. Ya en lo que es una plataforma, ya es como lo va a correr el usuario. Entonces yo empiezo mi carrera en Intel como ingeniera de validación. Después vino un cambio en mi carrera de la cuestión de semiconductores. Me muevo al área automotriz en una empresa alemana que se llama Continental Automotive. Ahí lo que yo me encargaba era hacer el diseño de plataformas que se usan en los clústeres de tractores de algunos clientes de Continental. Regreso a Intel como ingeniera de validación de Power. Me refiero a que valido la integridad de señales relacionadas con todo lo que son las fuentes. Vino un cambio gigantesco en mi vida, un cambio de 180. Me voy a un área de pre-silicon, a correr simulaciones para una empresa que en su momento se llamaba First Pass, que llegó a Guadalajara, ahora es Synopsys, ahora Synopsys ya está en Guadalajara. Para mí fue un cambiazo, porque fue un área de post-silicon, moverme a pre-silicon. Cambio a otra empresa, que en México se llama Solidigm, pero es la parte americana de Hynix. Entonces me voy a Hynix como Technical Product Lead. Me encargo de crear la estrategia de validación para los diferentes clientes de Hynix. Y finalmente, viene otro cambio para mí. Me voy a MICRON como manager de un equipo que ya les voy a platicar adelante, que se llama Media Hub. Yo nací en Toluca, 40 minutos de aquí. Ya saben que Toluca es famosa por el nevado, el chorizo. Entonces honestamente me dicen que soy chilanga, pero no, yo soy de Toluca. Estudié una ingeniería en electrónica en el Instituto Tecnológico de Toluca, que está en Metepec, no sé por qué se llama Toluca. Que ahora se llaman Institutos Nacionales de México, creo. Me muevo a Guadalajara y estudié una maestría en diseño de circuitos integrados en el ITESO, que es una universidad jesuita. Cuando termino la maestría, estudio un diplomado en Project Management, en gestión de proyectos. ¿Por qué lo hago? Porque me lleno de herramientas para poder saber cómo manejar los proyectos de manera más eficiente. Aquí no lo dice, porque está ongoing, y es una locura, no lo hagan. Pero estoy estudiando el doctorado en Ciencias de la Ingeniería. Recomendación, no lo hagan. Muy pesado un doctorado en Ciencias de la Ingeniería aparte de trabajo. Mejor háganlo separado. Pero espero que en algún futuro, ya cuando regrese y me den la oportunidad de nuevo, aquí ya diga PhD. Actividades fuera del trabajo, me encanta viajar. Me gusta hacer un montón de actividades fuera, al aire libre, mountain biking, senderismo, equitación. Me gusta practicar flamenco. Hasta hace año y medio daba presentaciones por parte de las academias. Y me gusta mucho aprender para compartir. Mi último reto es tocar violín. Entonces hace 2 semanas tuve una presentación con público así como ustedes. Fue un reto, pero lo hice. Hasta aquí un poquito de lo que soy. Les quiero platicar. Pegaba la computadora. Para poner eso no funciona. Denme un segundo. Permíteme. Claudia es bien buena onda, ¿eh? Me encanta ella. Les voy a contar una historia de una Ivonne cuando tenía 6 años. Cuando tenía 6 años, y muy acostumbrado a estar con su mamá y su hermana todos los domingos viendo una película. Nos sentábamos en el sofá a ver una película en una videocasetera VHS, que yo no sé si sepan lo que es una videocasetera VHS, pero era una caja metálica que metía cintas magnéticas en películas. La pusimos y de pronto se va la luz. Se va la luz y mi mamá me dice, Ivonne, ya revisar que los interruptores estén en la posición correcta. Ahora Ivonne, 6 años corriendo, solo le pidieron que viera si los interruptores estaban bien. Ahí va Ivonne, los ve y dice, ay, pero ¿y si lo toco un poquito? Nada más con mi pequeño dedo me acerqué, de verdad que lo prometo. Regreso a la casa, hay luz, y veo que mi mamá está peleándose con la videocasetera. Y yo, ¿qué pasó? Y me dijo, ¿qué hiciste? No, pues nada, es que ya no enciende. Y yo, ok. No le moviste, ¿verdad? No. Pero yo sabía que había tocado algo. No funcionó la videocasetera. Imagínense, echó a perder la diversión de los domingos. Mi mamá la tuvo que llevar al servicio. No, todavía no. Es de la... Yo la mujer. La tuvo que llevar al servicio. Pero en ese momento, a los 6 años, pareciera un detalle mínimo, ¿no? Un detalle chiquitín. Pero para mí fue tremendo, porque yo sabía que había algo que mi dedo hizo, que causó que se quemara la video. Era algo que yo veía en la luz, y era algo que yo sabía que encendía focos, pero se fue. Al mismo tiempo de que nació ese miedo, nació esa curiosidad. Pues, ¿qué pasó? ¿Por qué? Ese miedo me acompañó mucho tiempo, hasta que decidí entrar en la prepa. Decidí porque me preguntaron, ¿prepa o carrera técnica? Me fui al Cebetis, un Cebetis que está ubicado en un pueblo que se llama San Pablo Topan, que está cerca de la ciudad de Tónica, a 15 minutos o 10. Ahí estudié técnico en programación. Entonces estaba sentada programando. Y un día una maestra nos dice, oigan, les voy a enseñar a limpiar una computadora. Tráiganse sus desarmadores, el airecito. Abre el CPU y nos enseña la tarjeta madre. Entonces yo estaba fascinada, ¿no? Dije, wow. Y nos dice, aquí está el CPU, aquí está la memoria, aquí están todos los capacitores, resistencias. Y en eso nos dice, pero esta memoria, este CPU que ven aquí, es un transistor. Adivinen qué es un transistor. Es un interruptor. Imagínense que en ese momento Ivonne de 15, 16, regresa a la Ivonne de 6 años y se acuerda que con un interruptor quemó la videocasetera. Dije, wow, no, pues ¿qué estoy haciendo aquí? También me di cuenta a la par que la tecnología no solamente era software, era electricidad, física, química, matemáticas. Y vino una cosa importante a mí. En ese momento decidí, tal cual, decidí algo esencial. Decidí que no iba a huir del miedo, que lo iba a entender, que iba a entender por qué se había quemado la diversión de los domingos. Decidí que me iba a sentar a saber qué estaba pasando atrás de todo ese interruptor. Y estudié ingeniería electrónica. De las mejores decisiones de mi vida. Ahí fue cuando dije, pues me voy por la electrónica. ¿Qué es lo que puede pasar? Alguien súper, ultra, mega importante y un factor esencial en mi vida ha sido mi mamá. Ella sabía que yo tenía miedo, de verdad, yo no podía agarrar un cable porque yo sentía que lo iba a quemar. Yo veía cambiando un poco y me decía, enciende el foco, y yo no. Ella sabía, y cuando le digo, voy a estudiar ingeniería electrónica, me dice, ¿es en serio? ¿De verdad voy a estudiar ingeniería electrónica? Sí. Ella, un viernes en la noche, salía tarde de trabajar, y llega un día y me dice, Ivonne, mañana te vas a la escuela. Acabo de inscribirte a un curso de radiotecnia. Y yo, ¿y eso qué es? Mañana lo vas a inscribir. Ya sábado de la mañana, nos levantamos, llegamos a la escuela, una escuela de estas que Lucita te capacita, de estas escuelas técnicas. Llego a la entrada y veo 30 chicos. Y yo me quedo así de dónde estoy. Ella ve mi expresión en el rostro y me dice, ven, vamos a caminar. Caminamos, volteo a ver otra vez la puerta y le sigo. Doy vuelta, volteo otra vez a la puerta y le sigo. Y me dice, a ver, Ivonne, ¿sí te vas a animar o no? Y me acordé de lo que me había propuesto. No huir del miedo, sino entenderlo. Y le dije, va. Entro y fue la mejor experiencia, o una de las mejores experiencias. Tengo muchas muy buenas experiencias. Reparé mi primer ventilador, corté, metí, usé el multímetro, construí mi primera y única bocina desde cero. Me fui a, así como aquí, no me recuerdo cuál es la avenida, donde ven República, yo me fui allá, sí, yo venía aquí a comprar material que me tocó en el. Entonces, compré todo el material. Y algo bien interesante es que armé mi primer tarjeta, mi primer PC. No sé si lo sigan haciendo de la misma manera, si la tecnología avanzada. Si la tecnología avanzada tanto. Pero se acuerdan que compramos la tarjeta con cobre, trazamos los trazos y con el ácido férico la ponemos aquí. Y para acelerar el proceso lo ponemos bajo el sol, ¿no? O lo calentamos en una estufa. Pero no tenía estufa ahí en la escuela. El maestro dice, pues no tenemos mucho tiempo, necesitamos acelerar el proceso. ¿Cómo le vamos a hacer? Agarra un cable de luz, el otro cable de luz y los mete a la cubeta. Y yo me quedo, ¿en serio que va a pasar eso? Y veías cómo se bajaba la luz. Y me dicen, te va. Y yo, ok, no me voy a electrocutar, tú tranquila. Agarró el cable, agarró el cable, lo hice. Eso que me daba miedo, eso que hizo que echara a perder la diversión de los domingos en casa, lo tenía en mis manos. Y vinieron más retos. Eso era para entrar a la ingeniería, porque mi mamá decía, bueno, pues vas a estudiar electrónica, o sea, vas a tener que aprender a reparar televisiones. Ya ven que todos nos dicen, ¿me puedes reparar la televisión? O la plancha. O el celular. Eres ingeniero en electrónica, ¿no? El celular todo. Pero vinieron más retos. La cafetera. Entré al tecnológico de Toluca. Me acuerdo muy bien, primer semestre, mi primer clase de química. Entra el profesor, así en un aula, éramos 45 alumnos. Se pone enfrente, yo estaba en la segunda fila y empieza a contar. 1, 2, 3, 4, 5. Yo no sabía que contaba. Cuando termina de contar dice, una se va a casar el primer semestre, la otra se casa el segundo semestre, 2 van a abandonar la carrera el primer o segundo año. La quinta, y solo quizás, va a terminar la carrera. En ese momento me di cuenta que estaba contando el número de mujeres en el grupo de 45 personas. Fue algo que dolió. Dolió mucho porque sonó real, porque ella tenía experiencia y sabía que era verdadero. Dolió porque no fue una advertencia, fue una sentencia. Dolió porque nadie dijo nada. Dolió porque al final se cumplió. Fui la única que terminó. Y fui la única que terminó. Y no terminé porque no tuviera miedo, porque fuera la más inteligente. Terminé porque decidí que no iba a aceptar que alguien más escribiera mi historia. Durante la ingeniería, preguntas. ¿De verdad voy a estudiar ingeniería? ¿De verdad sirve para la electrónica? ¿Qué voy a hacer cuando termine la carrera? ¿Es en serio que hay trabajo en México? Matemáticas, física, química, fuentes conmutadas, transistores, electrónica de potencia, probabilidad, estadística, todo parecía demasiado. Yo creo que muchos, si no es que todos nos hemos sentido así, que es demasiado. Estaba platicando con un muy buen amigo, que un paréntesis, él también estudió electrónica, pero estudió a la par física aquí en el Poli. Entonces, estaba en Toluca y se venía. Por eso terminamos. De hecho, por eso terminamos. Pero a mí me gustó mucho Poli por él, porque él me lo compartía y decía, no, es que Poli. Entonces, paréntesis. Estaba platicando ya con él y le digo, es que mira, que las matemáticas y no sé qué. Y me dijo algo que pareciera muy sencillo, pero súper, ultra, mega importante. Me dijo, mira, Ivonne, todos somos ignorantes, solamente que ignoramos diferentes cosas. Ese pensamiento me liberó, se abrió el cielo. ¿Por qué? porque me dio permiso de aprender sin avergonzarme. Me dio permiso de decir, levantar la mano y decir, no sé, pero quiero aprender. Me dio permiso de avanzar, de crecer. Fue liberador y se los recomiendo. Y es algo que yo se lo repito mucho a mi equipo, por lo mismo de que preguntaban, oye, pues es que tú quieres que yo entre a trabajar y que sepa todo. Todos somos ignorantes, solamente ignoramos diferentes cosas. Y vinieron las retos. Terminé la ingeniería, terminé la maestría, entré a trabajar a varias empresas de diseño de semiconductores. Y el reto más importante, otro reto importante, cambié la torta de tamal por la torta ahogada. Me voy a Guadalajara. Algo que cambió mi vida completamente. Y vinieron más retos con ese reto de la torta ahogada y la torta de tamal.
¿La ahogada con salsa que pica o...?
Con ambos. No. Pero necesitan ir para probarla y adivinen qué pueden aparte hacer eso, ir a MICRON. Durante mis primeros trabajos en la industria, que fue en Intel, yo soy de las personas que pregunta, que comparte, que dice, oye, ¿cómo ves? ¿Cómo le haces? ¿Qué opinas? ¿Algún feedback? Etcétera. En Intel, uno de mis mentores, que se llama Rafael, le dije, oye, es que no sé cómo hacer, o sea, ¿cómo crezco? Y me dijo, mira, Ivonne, el crecimiento es cuestión de visibilidad. Visibilidad. Empiezas viendo el pasto, empiezas viendo la tierrita, las hormigas, etc. Conforme pasa el tiempo, ves los árboles, vas avanzando y tienes más experiencia. Y al final vas a ver el bosque. Visibilidad. Ahí entendí que nadie empieza viendo el bosque, pero eso no significa que no pueda llegar a verlo en algún momento. La confianza no llega antes del reto, llega después de enfrentarlo, llega después de que nos animamos a hacer algo, llega después de que somos capaces de aceptar que no sabemos todo. Como les compartía, he estado en varias empresas, varios roles, Intel, Continental, Solidigm, que se llama Jaime, Perspass, que ahora es Synopsys. Durante mi carrera dije, bueno, busco más. Llegó un momento, el año pasado, año y medio, donde me dije, quiero más desarrollo, quiero saber más, quiero aprender más, quiero generar impacto, quiero ver que lo que yo hago está llegando a personas que me encuentro en la calle. Quiero más retos, quiero más. Me puse a buscar, los cielos y los planetas se alinearon y llegó MICRON a Guadalajara. Y me dije, ay, fui a un evento como estos, donde ustedes están ahora mismo, pregunté, me acuerdo que me preguntan, ¿y tú qué buscas? Más bien vengo a ver qué me ofrecen. Dime qué quieres y yo veo y luego platicamos. Porque yo soy talentosa, yo soy inteligente, yo puedo con los retos. Dime tú qué tienes. Esto no es nada más de un solo lado, esto es de dos. Los valores de MICRON, cuando me empiezan a compartir toda la información, hicieron mucho clic conmigo. Colaboración, inclusión, innovación, excelencia, respeto y sobre todo la integridad. Ser congruente, lo que decimos con lo que hacemos. Y MICRON representa eso. No son solo palabras o discursos, sino son decisiones diarias que cada uno de los empleados de MICRON tenemos en nuestras manos. A nivel individual, a nivel grupo, a nivel empresa. Yo practico yoga y cuando vi el logo me gustó mucho, pero me hizo más sentido cuando una persona de mi equipo, un chico se llama Raúl, mide casi 2 metros y está fornido el muchacho y está chico, tiene 24 quizás, Un día nos piden en la empresa un networking, que eso lo hacen recurrentemente, y nos pidieron que lleváramos algo que nos hiciera sentido con la empresa. Él llevó esto, una macetita que mide 10 centímetros, un hombrezazo de 2 metros. Y nos cuenta la historia. Y nos dice, cuando me aceptaron, para mí fue wow. Llegué contándoselo a mi mamá. A mí me gustan mucho las plantas, pero bueno, Raúl, hablando por Raúl, pero Raúl no puede tener plantas porque se le muere. Entonces su mamá le dijo, te voy a regalar esto. Y le regaló la macetita, un elefantito de 10 centímetros. Ese elefantito, Raúl, hablando ahora yo como su mamá, Raúl, ese elefantito eres tú, porque eres mi bebé, eres mi chiquito. Pero también eres el elefante que representa fortaleza, eres el elefante que representa resiliencia, eres esa persona fuerte que tú puedes ser. A mí, como madre, cuando me cuenta la historia, me dice, me hace sentir y le digo, oye, ¿por qué se conocen los elefantes? Porque tienen buena memoria. Ah, ¿verdad? ¿Y a qué se parece este elefantito? Parece un elefante, ¿no? Dije, qué inteligentes son los de marketing de MICRON. ¡Wow! MICRON Memory, elefante. Y de nuevo, a mí me hizo sentido porque, les digo, yo platicando con mi maestro de yoga, me pregunta, oye, ¿y cómo tú trabajas? Y digo, aquí es, le enseño y luego me dice en mi mente, ¿es un elefante? Sí. De nuevo, habla de la cultura que trae atrás. Entonces ahí digo, wow. Dentro de MICRON yo trabajo en un equipo que se llama Media Hub. Este equipo cuida algo importantísimo en el producto ya terminado, la calidad y la confiabilidad de esos productos. Productos que millones de personas alrededor del mundo usan diariamente. Celulares, computadoras, carros, AI, CPUs, GPUs, etc. Esas millones de personas jamás van a saber nuestro nombre. ¿No? Algo que escuchamos recurrentemente es que la ingeniería es resolver problemas, pero también es asumir responsabilidad. Asumir la responsabilidad de que lo que hacemos tiene impacto. Saber que lo que hacemos importa. Y saber que lo que hacemos como ingenieros cambia las cosas reales. Porque de nuevo, trabajamos con tecnología que millones de personas usan diariamente alrededor del mundo. Después de todo lo que les he contado, hay un pero el síndrome del impostor me acompaña diario. Las dudas. ¿Soy merecedora a estar donde estoy? ¿Soy suficiente? ¿Estoy tomando la mejor decisión para mi equipo? ¿Soy la mejor manager para mi equipo? Dudas, 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 dudas. Aprendí que el síndrome del impostor no se vence, no hay que pelearlos, hay que entenderlo. Mi meta del síndrome del impostor es llegar al síndrome de la grandiosidad. Y dije, bueno, ¿cómo lo voy a hacer aquí? Es un proceso. Es un proceso que conlleva trabajar en conjunto, buscar mentorship, buscar compañeros, buscar asesorías, pedir retroalimentación. Oye, profe, ¿cómo le hago aquí? No le sé hacer aquí. Y cuando el profesor les diga, es que están los libros, sí, pero no le entiendo. Oye, ¿pero ya lo leíste? No. Es buscar esa retroalimentación. Oye, Claudia, oye, Víctor, yo voy aquí, ¿cómo le hago? Me interesa esto, me interesa aquello, ¿qué tengo que hacer? ¿Qué tengo que hacer para empezar a ver ese pasto? Porque yo quiero ver el bosque. Pero sobre todo es autorreconocimiento, amor propio y reconocer todo el trayecto que hemos hecho. Abrazarnos, vernos día a día frente al espejo y decir, estoy en el Politécnico, no cualquiera. Y voy a terminar, y no cualquiera termina. Es todo un proceso. En MICRON estos crecimientos no se hacen solo, y no deberíamos de hacerlo solos, independientemente si estamos en Micron o no. Algo que me gusta de Micron es que existen los Micron ERG que se llaman Employee Resource Group. Estos grupos son comunidades, o son grupos formados por empleados de Micron y liderados por empleados de Micron. La intención es que las personas con similitudes, intereses afín, nos juntemos y busquemos exponenciar talentos. El impacto de estos ERGs es a nivel económico, porque cuando Micron está apoyando que el empleado se sienta a gusto, crezca, los resultados se notan en el trabajo, en nuestros entregables, en esa excelencia, en esa innovación. Es algo que aprecio realmente. También hay grupos que se encargan de fomentar la ingeniería en chicas. Por ejemplo, no sé si han escuchado algo de Technovation. Technovation es un programa a nivel mundial. Micron está empezando a hacerlo. O trabaja con universidades, en este caso ITESO, por ejemplo, para hacer sponsorship de chicas que se ganan becas para estudiar ingeniería en el ITESO. También tiene impactos en la comunidad. Hay grupos que trabajan de voluntarios y, por ejemplo, pueden apoyar a personas que por alguna otra razón, de manera lamentable, han sufrido cáncer. Y también a nivel individual, si alguien tiene algún interés, por ejemplo, yo soy parte de algo que se llama MWLN, que es Micron Woman Leadership Network, donde nos juntamos y trabajamos para poder exponenciar las habilidades en mujeres, sobre todo habilidades de liderazgo. No lo hacemos solos, de nuevo, hombres, mujeres, como aliados. Actualmente, ya que me puse, cuando estaba haciendo esta presentación, y me acordaba de la videocasetera, y me acordaba de las dudas, me puse a pensar en ustedes, estudiantes, personas que van a egresar, o personas que a lo mejor ya tienen una experiencia laboral y que están buscando un reto. Y que cada vez que ven una vacante dicen, uy, no sé CAD, no sé RTL, nunca he usado Synopsys porque son herramientas caras y privadas. Y las versiones estudiantiles a veces no son tan accesibles. Exactamente. Que vemos el checklist y vemos y decimos, ¿cómo voy a aplicar si no sé nada de eso? ¿Cómo le hago? También me preguntaba, ¿cuál será la videocasetera de ellos? ¿Cuál es la videocasetera de ellas? ¿Qué es lo que les causa ese miedo? Diversas, un montón de opciones. Déjenme decirles algo mirándole a los ojos. Algo de ingeniera a ingeniero. Algo de ingeniera a ingeniera. Las bases importan mucho y lo mencionó Justin. Pero lo que cambia es la perspectiva. No necesitamos saber todo para empezar. No necesitamos saber todo para empezar a ver ese pasto. Porque es un progreso, es paso a paso. MICRON, de nuevo lo menciona Justin y yo creo que todos los que estamos aquí lo sabemos, busca personas que quieran aprender, personas que quieran saber más, personas que sean curiosas, que pregunten, que a través del análisis de datos tomen decisiones y que hagan impacto en esos millones de personas que usan la tecnología. Personas que quieren alcanzar el éxito, lo que sea bajo su definición del éxito. Personas que quieren generar esa confianza en sí mismos a través de lograr otras metas. Personas que no huyen del miedo, que quieren entenderlo. Eso es MICRON. ¿Cómo lo vamos a hacer? Empezando. Ensuciémonos los zapatos con la tierra, vayamos, pisemos el pasto, quitémonos los zapatos, caminemos descalzos. Empecemos, porque si no, un solito no va a llegar. Aprendamos. YouTube, Coursera, cursos de la UNAM, cursos del Poli, libros, herramientas, hay un montón. Mantengámonos constantemente aprendiendo. Preguntemos. De nuevo, no tiene nada de malo preguntar y no tiene nada de malo decir, no sé. Malo está llegar y decir no entiendo y no haber trabajado antes, ¿verdad? En tener una pregunta específica, clara, concisa. Pero lo que yo les diría, lo más importante, conecta. Asiste a estos tipos de eventos. Si la UNAM tiene una feria de trabajo que es abierta al público, voy a la UNAM. Si el TEC, si el TEC de Monterrey, si la UP, si universidades privadas tienen eventos de ferias como ese tipo, voy. Conecten. Hay una experiencia que se me hizo muy interesante. El año pasado, supongo que saben lo que es el Talent Land. El año pasado, en abril, me tocó ser panelista en uno de esos eventos. Ya termino, se me acerca una chica y me dice, hola Ivonne, fíjate que yo soy de la UNAM, voy a terminar la ingeniería, me gustaría saber si me puedo tomar una foto contigo. Y fue así como que, wow, yo soy importante. Se toma la foto. Y me dice, ¿cómo ves? ¿Cómo están las carreras, el trabajo? Le digo, pues si quieres, mándame un correo, te paso mi WhatsApp y cuando termines me contactas. Noviembre del año pasado, me manda un correo, me manda un WhatsApp y me dice, hola, soy fulanita. Y cuando me dice el nombre, yo dije, ¿quién es? No me acordaba. Me manda la fotografía que nos tomamos juntas. Y me dice, soy fulanita, nos conocimos en el Talent Land, acabo de egresar y quiero entrar. Después, compartiéndolo con Claudia, me di cuenta que no fue la única que lo hizo. Qué muchacha tan inteligente. Porque sabemos que sabía que se le iba a olvidar el rostro. Cuando me manda la foto, dije, ya sé quién eres. Ya sé lo que platicamos. Ahorita ya estoy trabajando en el grupo de Claudia. Va, conectemos, tomemos ventaja de este tipo de eventos. No hay nada de malo de no en preguntar. ¿Cómo le hago si quiero trabajar en esto? ¿Cómo le hago si quiero hacer esto? Aquí también buscamos crecer, vayamos por ese reto, por ese éxito que estamos buscando. Porque cuando hablamos de crecer, de generar esta confianza, hablamos de creer en nosotros, hablamos de visibilidad, de ver el pasto, ver los árboles, ver el bosque, hablamos de resiliencia. No nada más es, sí, me voy a titular, sí, voy a trabajar. Hablamos de muchas otras cosas que no alcanzamos a ver. Hablamos de trabajar unidos, hablamos de preguntar, de buscar mentorship, de preguntar a las personas que ya saben, que han pasado por ese camino, cómo le hacemos para mejorar. Aquí en este punto les quiero pedir un favor a cada uno de ustedes. Seamos personas que cambian la narrativa de ese profesor de química de primer año de Ivonne, que dijo, no van a terminar. Si acaso, ayúdenme en eso, seamos esas personas. Asegurémonos de cuando un futuro ingeniero, una futura ingeniera entra a un salón de clases, no vea una predicción de fracaso, sino vea un futuro lleno de posibilidades. No es necesario que seamos maestros nada más, esto es responsabilidad compartida, como compañeros de clase, como personas que trabajamos en las universidades, en las empresas. Apoyémonos los unos a los otros. Y aquí, ya para terminar, yo tengo una pregunta para ustedes, una pregunta importante, una pregunta esencial. Que no me tienen que responder a mí, prefiero que se lo respondan a ustedes. ¿A quién voy a ver el MICRON? Gracias. ¿Alguien tiene alguna pregunta, algún comentario? ¿Alguien quiere agregar? ¿Experiencia compartida?
Yo no pregunta, pero sí fue muy inspiradora la plática. La verdad es que siento que especialmente como mujeres es complicado todos los retos que se ponen día con día, pero sí fue muy inspiradora y pues muchas gracias por darte el tiempo de elegir cada palabra, yo creo que muy correcta.
Gracias. ¿Alguien más? ¿Ya compartir algo?
Sí, bueno, pasa muy seguido que los ingenieros, o alguien que está muy relacionado con las ciencias y la tecnología, le gustan aparte otras cosas, ¿no? Como en este caso, le gusta el violín, ¿no? Cuando habías que tuviste una presentación, está también a mí me gusta la música. Y también varios de mis estudiantes les gustan los idiomas o los videojuegos, juegos de rol.
Sí, hay que diversificar los talentos.
Les digo, pues sí, está bien porque no todo es el estar, digamos, viendo estos temas de electrónica, de física, de matemáticas, computación, sino también pues hay que abrirse a esas posibilidades porque finalmente pues nuestra mente es como inquieta, siempre está así como pensando.
Trabajando. Sí. Gracias. ¿Alguien más que quiera compartir algo o preguntas? ¿No? Oh.
Bueno, uno que es, por ejemplo, yo soy de Tecnológico de Catepec, o sea, también como habías mencionado de los TECNM, que ya son como escuelas, pues universidades aparte, ¿no? Tú vienes también de, bueno, un instituto aparte. Quiero saber cómo fue para ti enfrentar ese cambio de que, por ejemplo, todos nos comparamos luego con el Politécnico, la UNAM, la UDG, que supongo que están más preparados, tienen estos enlaces. ¿Cómo recomendarías dar también ese salto para pues, la competencia luego en el mundo real, ¿no? Ya dar ese salto? Y si sientes que realmente es importante o en cualquier universidad no tiene como un reto o algo más que prepararse o ajustarse.
Qué difícil. Les voy a contar mi primera experiencia cuando fui a una entrevista. Salí del TEC y en Toluca está cerca la Nissan. Entonces yo vi una vacante y dije, pues voy. ¿Qué es lo peor que puedo perder? Yo iba a ir con un pantalón de mezclilla y una camisa. Pero me ve mi mamá y me dice, ¿a dónde vas? No, voy a entrar a trabajar a la Nissan. No, estás mal, te pones traje. Y ahí vamos, se pone traje. Llego a la entrevista. Y perdón por el nombre, pero it is what it is. Entonces llego y todos los chicos trajeados. Yo hablé con un tío que también era ingeniero, y era porque falleció. Le dije, oye, ¿cómo le voy a hacer? Y me dijo, pues diles a los japoneses que no hablas inglés. ¿Por qué? Porque en la época en la que yo estuve en el TEC no era como algo que se reforzara mucho el inglés. Yo sabía que tenía que hablar, pero pues no había internet. O el YouTube, o como estaba así accesible. Me dijo, pues diles, tienes que ser honesta. Eso fue mi primera idea, ¿no? Dije, bueno, que voy a ser honesta conmigo misma, me voy a preparar. Llego a la entrevista, todos los chicos trajeados del Politécnico y del TEC de Monterrey. Vamos a la entrevista. Llego, me pasan, y el reclutador me dice, a ver, ¿por qué te interesa Nissan? Sin mentirles, yo estaba respondiendo y él estaba jugando con la pluma. Cuando noto eso, me quedo callada. ¿Por qué no me estaba poniendo atención? Me quedo callada, no digo nada, me ve y dice, perdón, ¿qué me decías? Salí de la entrevista, muy mal, muy enojada, porque dije, ya sabes que no te vas a quedar ahí. Estamos en la entrevista y veo que hay varias personas, empiezan a hablar los chicos, no, pues es que en el TEC, o es que, sobre todo en el TEC, nos van a ganar los del Poli, ¿no? Me acuerdo mucho de eso. Y yo decía, oye, el Poli, en mi mente, estoy con los del Poli. Pasó, fue una buena experiencia, porque me di cuenta, de nuevo, que tenía que aprender, que no tenía que tener miedo, no me iba a echar para atrás, tenía que salir adelante y tenía que mostrar mis capacidades. Fue difícil, no fue lo más fácil del mundo, pero a partir de ahí, por ejemplo, yo sabía que me fallaba el inglés, o lo tenía lo básico, lo técnico, el inglés técnico es más fácil. Todos los fines de semana me iba a Sanborns a comprar el periódico en inglés y me ponía a leer. Dije, no, a ver, a mí el inglés sí o sí. Fui a Guadalajara, pregunté, oigan, ¿aquí de qué se trata? Estuve en el Sinvesta de Guadalajara, pregunté.
¿Susana?
Sí, con él.
Perfecto.
Y sin miedo. O si tenemos ese miedo así como que, de nuevo, fue una experiencia enriquecedora, ahora lo veo y estoy agradecida por ello, porque de nuevo, viendo en retrospectiva, si me hubiese detenido, si no hubiese sentido esas ganas de crecer, no hubiese avanzado. Fue difícil, de nuevo, no es lo más fácil, pero hay que hacerlo. Hay que identificar cuáles son nuestras carencias. Por X, ahorita la tecnología es muy abierta, todo el mundo. ¿Quieres aprender mandarín? Por ejemplo, tomo clases de mandarín una vez a la semana, está fácil, pero no hay tiempo. Entonces con mi maestra le digo, ay, ¿sabes qué? Te voy a cancelar hoy. Dice, ok, apréndete nada más el ni hao. Ni hao. Voy a las 2 semanas y me dice, ¿cómo vas? Y yo, pues ahí voy. No, va súper bien. Déjame subir. Pero de nuevo es no saber, porque alguien de mi equipo me decía, es que yo quiero hacer todo esto mañana, el pasado mañana y en un año terminar. Le dije, mira, está muy bien, pero también tienes que aprender a ir un poco más despacio. Y no te estoy diciendo que no, te estoy diciendo que sí lo vas a lograr, pero un poquito más lentito. Es aprender ese tipo de cosas, ¿no? De nuevo, mucho autorreconocimiento. ¿Alguien tiene otra pregunta? ¿Comentario? ¿No?
Bueno, yo quería comentar que con toda su plática me quedó mucha motivación a seguir persiguiendo sobre todo esta empresa. Ya había investigado mucho de ella y ahorita que tengo que empezar a ver dónde hacer mis prácticas profesionales en la universidad, yo soy de Tecmilenio, pues sí me dan muchas más ganas de trabajar, sobre todo con cómo se conecta con mis valores personales, los valores de la empresa, para poder dejar mi granito de arena.
Gracias. ¿Sí lo logramos? ¿Alguien más? A ver, ya compartí. ¿No? Bueno, de nuevo la invitación a que pregunten, platiquen con Claudia, con Víctor, con Marina, con Justin, de verdad. Si no sabemos hacia dónde vamos, hay que preguntar. Si no, nadie va a venir a decirnos, hey, dale por aquí. Un gusto y gracias de nuevo.